Hello, my name is Batiste, and I'm going to be explaining the Nash Equilibrium. We'll start with a formal definition of what the Nash Equilibrium is. Nash Equilibrium, a stable state of a system that involves several interacting participants in which no participant can gain by a change of strategy as long as all other participants remain unchanged. So it's a little bit complicated. So if we break it down, there's a few criteria that are explained in that definition. The first being that no participant can gain from a change of strategy. This means that in order for Nash equilibrium to be true, no participant can gain from changing their strategy. Now, if one participant is changing their strategy and you're testing that outcome, all the other participants have to keep the same strategy. Now, in order to figure out if it's Nash equilibrium, you have to have gain or benefit be specified in the model. So we have to define that. So in order to determine where the Nash equilibrium is true in a situation, we use a payoff matrix. This helps to visualize and determine the outcome. A payoff matrix is a grid that one side is represented by player one, and the boxes within represent the different choices or strategies that the player can choose between. The other side is player two, and it's the same goes for the choices that they can choose between. Now there are two numbers in each box. One number represents the value that comes from the decision to choose that outcome, and each number corresponds to a different player. Now, this number determines the value that the box represents. Now, if we want to try this out on a specific model, we will have company one and we have company two. Company one, for example, is selling products, and they have the decision to either advertise or not advertise. Now, company two has the same decision to not advertise or to advertise. And in situation box in the lower right, this is where both companies make the decision or decide the strategy to not advertise. Now, if this were the case, they would both make the same amount of money, assuming the companies are of similar scale. And this is all right for both companies. Now, if company two decides to advertise, they will resultingly make more money. They have a greater profit. This will draw some of the customers from company one, so company one will be making less money if they continue to choose to not advertise. Now, this goes the same way for company one deciding to advertise. They're going to make a greater income. Company two will have a lower income. Now, if both companies decide to advertise, they're going to draw more traffic to their company and make more money, yet they're going to be both stealing each other's customers and will make less money than if they both don't advertise. Now, in order to figure out the Nash equilibrium, we have to look back on the different criteria where no participant will gain from a change of strategy, and the other participant has to stay consistent with their choice. We have to choose a scenario. We're going to choose the bottom right box. Now, we have to test from a specific point of view. Now, if you look at this situation from company one's point of view, company two has to stay consistent with their choice. This means that we cannot move vertically between the boxes. And this means that the only choice we have is to move from right to left. And in this case, this is actually beneficial for company one. Company one decides to advertise where company two is not. Company one is going to make more profit. So this means that this is not a Nash equilibrium because it is beneficial for one of the participants to move and change their strategy. In order for this to be a Nash equilibrium situation, no participant can gain from the change in strategy. So if any of the participants gain from it, it's not a situation where Nash equilibrium is true. Let's try it again for this green circled scenario. We're going to look from company one's point of view again. That means that company two will have to stay constant, so we cannot move vertically. This means that if company 1 is not advertising where company 2 is, and company 1 decides to advertise, they're going to make more money than before. So this is not a Nash equilibrium because company 1 will choose and benefit from changing their strategy. So we have our first two trials. Both of them are not Nash equilibrium. Now we are going to try it again for the bottom left. And in this case, company 1 has to stay constant, so we're only moving vertically. Company 2 decides to advertise. They are going to be making a increased profit, so this is beneficial. So that is also not a Nash equilibrium. We have one situation left. This is where both companies decide to advertise. And in this case, we are going to look at it from company 1 again. Company 1, if we move vertically, will benefit from this by making more profit. Now, we cannot actually do this because, as stated in the criteria, the other participants have to stay consistent. So company 2 has to stay consistent. We cannot move vertically, so that is not the case. Now, the only option we have is to move horizontally from left to right, and this is not beneficial, so company 1 will not decide to change their strategy. Now, we can see this again. Company 2 has to move vertically, and it's not beneficial, so it's not beneficial for either participant to change their strategy. So this means that this is a Nash equilibrium. This is the scenario where Nash equilibrium is true in this model. Thank you for watching. Hope you have a great day.